look at this question. The velocity time graph is given. Find the displacement of the body in 8 seconds. We know that in the from the velocity time graph we can find the displacement. The displacement is area under velocity time graph. So from which time to which time? From 0 second to 8 seconds. From 0 second to 8 seconds. What is the net displacement of the body? This is velocity time graph. So just find out the area. Okay, just find out the area. Let me copy this figure again. 1 minute. Okay, so we have to find the displacement from 0 second to 8 seconds. 0 second is here, 8 second is here. Between 0 and 8, what is the total area? That will be the net displacement. The total area. Remember, the area above x-axis is considered as positive, but area below x-axis considered as negative. So from 0 second to 8 second, what is the net displacement of the body? We have to find the total area from 0 to 8 seconds. The area will be this area plus this area plus this area. That will be the total area. I mean, this will be the area between 0 and 8. Now the total area. The total area will be this area, let it be A1. This area, let it be A2. This area, let it be A3. But the sign to be considered. The sign should be considered. The area above x-axis should be positive. The area below x-axis must be negative. Otherwise, you will get wrong answer. So this A1, what is this A1? The total area will be, first of all, let me find out A1. This is a rectangle. Length into breadth. Length into breadth will be the area. Length is, what is this? This is 5, right? Between 4 and 6, this is 5. Okay, length will be 3, right? Yes, 3. This one is 3. Length into breadth is the area. Length is 3. Breadth is this one, vertical one. What is this? This is 5. It will be 15. Is it okay? Clear? Next, I am going to find out A2. You will automatically get A2 as negative. Don't worry. Okay? You will automatically get A2 as negative. I will tell you. A2, it's also a rectangle, correct? Length into breadth will be the area. What is this point? This is 3, right? This is 3 and this is 5. The distance between 3 and 5 is 2. Is that correct? Distance between 3 and 5 is what? 2. You will automatically get negative number, don't worry. And what is this? Look here. Minus 2. Understood? Minus 2. CD. The sign is there. Minus 2. Understood? CD is minus 2.
Yes, sir.
You will get automatically, you will get negative number. Okay. Don't worry about that. So A2 is clear. Now A3. A3 is a rectangle. Length is the distance between 5 and 8. It is 3. 8 minus 5. Like, understood. 8 minus 5. 3. This length is 3. And the height is what? The diagram is not so perfect. Just like approximation thing, like approximation, the diagram is not so perfect. I think that if we extend it towards left, it is 4. I think so. So let me take 4 or okay, for 4.5. Anyway, I want the approximate value. The figure, this is a problem with the figure. GH, if you extend it towards left, I think it is 4.5. I think so. 4.5. Let me take it. Take it as 4.5. It's it's a problem with the figure. Okay, look at this question. Figure shows velocity time graph. Okay, the figure shows velocity time graph. Compute the acceleration of each phase of the motion. This is what? Velocity time graph. Compute the acceleration. Describe how the object moves during the last time segment. Last time segment. I mean, I think it is about EF. Okay. Describe how the object moves during the last time segment. Okay. So listen. First part is important one. Compute the acceleration. O to A. Can you tell me what happens O to A? Let us consider each segment OA. From O to A, the velocity is 0. Understood? Clear? From O to A, the velocity is 0. Is it correct? Please respond. Natasha?
Yes, sir.
Yes, sir.
O to A, the points are on x-axis. O to A, no velocity. No velocity means velocity 0 means the body is stationary. Velocity 0 means the body is stationary, not moving at all. No motion. That is no motion. So no motion means no acceleration, right? From O to A, no acceleration. Next segment is A to B. Next segment is what? A to B. A to B, yes, the velocity is increasing. Understood? Look at this diagram. As the time changes, the velocity is increasing. The velocity is changing, right? So acceleration is there. I explained in the previous class that if the velocity time graph is a line, it is moving under a fixed acceleration. I explained in the previous class. If the velocity time graph is a line, that motion is a motion under fixed acceleration. It's very simple. I will tell you how to find the acceleration. It's very simple. I will tell you. Consider the segment A. The segment A, A is where is A? Let me write the code. Tell me. A is what? At A what happens? At A what happens? A means that. Oh, the step is not required. A means what? A says that when time equal to 1 second, velocity equal to 0. Let it be initial velocity. A means what is the time there at A? What is the time there at A? It is 1 second, correct? It is 1 second. So at 1 second, the velocity is 0. Is it correct? You agree with me? Is it correct? When time equal to 1 second, velocity is 0. Next, you just consider any 2 points. B. Now let us consider B. B means time equal to 3 seconds, right? B means time equal to what? 3 seconds. When time equal to 3 seconds, what is the velocity? Look at this. B. B means at B, the time is 3 seconds. And at that instant, the velocity is given as 8 meter per second. Clear? When time equal to 3 seconds, the velocity is 8 meter per second. This method is much convenient. Okay? You will never make a mistake if you write like this. So when time equal to 1 second, the velocity is 0 initially. When time equal to 3 seconds, the velocity is 8 from the diagram. A to B is a line. The body is moving under a fixed acceleration. Acceleration is change in velocity by change in time. Change in velocity by duration or change in time. We studied that in the beginning. You can avoid some steps. Change in velocity will be 8 minus 0, correct? Change in velocity will be 8 minus 0. Final minus initial. Okay, change in time will be 3 minus 1 duration. Acceleration is change in velocity by change in time. It will be 8 by 2 or 4 meter per second square. The next segment after BC and CD. Okay, BC. Let it be BC. It's a lengthy problem actually. BC. After that, I will consider CD. BC. BC at B. What is the time? At B, what is the time? Look at this diagram. At B, the time is 3. I have already explained that when time equal to 3, the velocity was 8. The velocity was 8. Now, the end point is C. The end point is C. C means time is 5. C means time is 5. Here, when time equal to 5, the velocity is 0. See, understood? Velocity is 0. When time equal to 5, velocity is 0. Now, let me reduce some steps. Change in velocity. Final minus initial. The order is very, very important. Change in velocity by change in time. Final minus initial. The order is very, very important. Acceleration is change in velocity by change in time. Minus 8 by 2. Yes. Minus 8 by 2. Acceleration is minus 4 meter per second square. Meter per second square is the unit of acceleration. Okay. Next is after BC, CD. Now the remaining steps are easy, but let me complete it. CD, C. C stands for C. What do you mean by C? C, at C, the time is 5. At C, time equal to 5. At C, time equal to 5, velocity 0. Then D, final point. At D, time is 8 seconds. Time equal to 8 seconds. Time equal to 8 seconds, but what is the velocity when time equal to 8 seconds? The velocity is minus 12, I think so. Okay, minus 12. When time equal to 8 seconds, velocity is minus 12. From the graph. Initially C, finally D. Okay, you have to note the time and velocities. Then the method is simple. The body is moving under a fixed acceleration because it is a line. Change in velocity by change in time. So minus 12 by 3 minus 4 meter per second square. So DE, the segment DE and EF will be a homework. The second part, let me discuss the second part. Describe how the object moves during the last time segment. The last time segment, I understood this one. I think they are talking about, they are talking about this one. This one. Can you see that? EF. This is the last time duration. I understood? Clear? Last time segment is EF. After that, nothing is marked. So EF, what does it mean actually? What is the nature of the motion during this time interval? Nature of the motion. So that part I will discuss. The EF, you see that the body is moving under a fixed velocity. The body is moving with a fixed velocity minus 4. Describe how the object is how object moves during the last time. We have to find out the complete information. Not only acceleration, but also moving forward, backward, every complete information I want. From E to F, the body is moving from E to F. What kind of motion is this? From E to F. So you can see that from E to F the velocity is fixed. The velocity is -4. Velocity is fixed means no acceleration. Let me write here EF. B part I am discussing. EF. The fixed velocity. Body is moving with a fixed velocity. So no acceleration at all. If the body is moving with a fixed velocity, no acceleration. Not finished. Is the body moving towards right or left? For example, if the car is moving along a road, is it moving towards right or is it taking reverse? You get the sign of the velocity. From E to F, the velocity is negative. In the beginning I told you that positive velocity means moving forward. Positive velocity means moving forward. Negative velocity means moving backward. The body is moving backward. Body is moving backward. With a speed of 4 meter per second. When we talk about speed, the sign we will not show. In the case of speed, the sign is not required. So -4 velocity means that the body is moving backward with a speed of 4 meter per second. The body is moving with a fixed speed 4 meter per second backward, no acceleration at all. A car moving along a straight highway with a speed of 126 km per hour. This type of question is there in the chapter laws of motion. But let me discuss. A car moving along a straight highway with a speed of 126 km per hour is brought to a stop within a distance of 200 meters. What is the retardation of the car and how long does it take the car to stop? So here what they are saying, remember this is not the unit of velocity. The unit of velocity must be meter per second. Very, very important. The unit of speed or velocity must be meter per second. In the lower classes you studied that kilometer per hour can be converted to meter per second. How? Kilometer per hour can be converted to meter per second by multiplying with the 5/18. Please remember this. It's very important. Don't forget. Kilometer per hour must be converted to meter per second by multiplying with the 5/18. A body has the initial velocity u equal to 126 km per hour. Must be converted to meter per second. Multiply with the 5/18. What is the value? Let me check it. 126 into 5/18. 126 into 5 divided by 18 will be 35. Initial velocity is 35 meter per second. A body was moving with the initial speed 35 meter per second. And it traveled a distance. The distance traveled by the body is 200 meter. And finally it stopped. Is it correct? Brought to a stop. Yes. The final velocity is given as 0. Stopping means the velocity 0. You know that. Retardation. What is the retardation? I mean acceleration is our question. The acceleration with a negative value is said to be retardation. Acceleration itself, it will have some negative sign, that's all. So we have studied 3 formulas in the previous class. I want acceleration. So look at these terms. U is there, V is there, S is there, A I want. UVAS. UVAS. Is there any formula connecting these letters? UVAS. We studied 3 formulas in yes, I will tell you. UVAS. There is a formula connecting these letters, which is v square equal to u square. Yes, v square equal to u square plus 2as. So in this type of question, just draw a rough picture, highlight the variables given or the variable we have to find out. Highlight everything and look at these terms, variables, which formula contains all these three variables. V square equal to u square plus 2as. V square is 0 square. U square is 35 square. 2 into a into s. S is given as 200. So 0 equal to 35 square is 1225. 2a into 200 will be 400a. 1225 taken to left hand side. 400a equal to minus 1225. Or a equal to minus 1225 divided by 400. So it will be equal to 1225 divided by 400 will be 3.06, approximately 3, no problem, approximately minus 3 meter per second square. Retardation means it is acceleration having negative sign, that's all. Okay, clear. Motion. Look at the graphs from A to D carefully and state with the reason which of these cannot possibly represents one dimensional motion. The first one is position time graph. How? First one is position time graph. X stands for position. A car is moving along a line. A car is not moving in a curved path. Car is not moving along a curved path. The car is moving straight. The position versus time is plotted. The position of the car versus time is plotted. Position time graph. Does it represents one dimensional motion? I will explain. Okay, I don't want to spend time. I will explain. This graph is impossible actually. This graph is impossible. Why? We are talking about one dimensional motion. A body is moving like this, moving along a line. We have plotted the position versus time at different times, 1 second, 2 second, 3 second. We have noticed the positions. You will never get a graph like this. It is impossible graph. Why? I will tell you. For example, there is a time here. Let it be say 2 seconds. Can you see a time here? At 2 seconds, where is the position of the car? The position will be, let me draw a vertical line like this point and this point. I will draw it again. I think it is much better. 1 minute. I will draw it one by one. Okay, one by one I will explain that. I want to enlarge this diagram, otherwise you cannot understand. Okay, let us study the first graph. The first graph is xt graph. This graph is impossible because, for example, there is a time, say 1 second. Let me draw a vertical line like this. This graph says that when time equal to 3 seconds, the body has two positions. Say this position be say 2 meter. Write some number there. Write some number there. And let this number say write any number. So this graph says that when time equal to 1 second, the car's position is both 2 meter and 4 meter away from me. it is meaningless. It is meaningless. It is absurd. Absurd എന്ന് പറഞ്ഞാൽ ഇത് മണ്ടത്തരാണ്. എങ്ങനെ കാറിന് ഒരേ സമയം രണ്ട് പൊസിഷൻ വരാം? ഇറ്റ് ഈസ് ഇമ്പോസിബിൾ. ഞാൻ പറഞ്ഞത് ക്ലിയർ? ആർ യു ഓക്കെ? ക്ലിയർ? അണ്ടർസ്റ്റുഡ്? ഇസ് ദാറ്റ് ഓക്കെ? Nadasha?
Yes, sir.
Clear. So whatever be the motion, okay, whatever may be the motion, this graph impossible to occur. So let me write the reason here. At a given time, the body has two positions, which is impossible. So this never represents one dimensional motion. Okay, let me write no. Okay, answer is no. Okay, answer is no. The reason is written here. This graph never represents one dimensional motion. Look at this. This is a velocity time graph. But the problem is there because at a given time the body has two velocities. It is impossible. For example, consider some time, say 1 second or 2 seconds, whatever. Draw a vertical line. So at 1 second, I have the velocity, say 3 meter per second, as well as minus 3 meter per second. Write some number here. Otherwise you will not get good idea. So at a given time the body has two velocities. It is also impossible. At a given time the body will have a one velocity, not two velocities. Clear? Understood? So this never represents one dimensional motion, because at a given time, here the reason is the body has two velocities, which is not possible. So it is not velocity time graph, it is speed versus time. Speed versus time. This graph is not possible, because when we talk about speed, we will not consider the negative sign. Whether the body moving forward or backward, we will not write the speed as a negative number. Understood? But look at this graph. At certain time the speed becomes negative. For example, let's say 4 seconds. What is the speed? The speed is a negative number. The speed is a negative number. Speed cannot be negative. Velocity can be negative, but when we talk about speed, we will not mention the sign. So speed cannot be negative. So this does not represent one dimensional motion. Speed cannot be negative. Okay, the reason. Speed cannot be negative. Look at this. Does it represent one dimensional motion? Total path length is the distance. Actually the total path length is the distance. Here this does not represent one dimensional motion, because I am walking, or sometimes I do not walk. Okay, I agree. When I walk, what happens? If I walk, the path length will be increasing. Suppose initially I am standing at A. I am walking. While I am walking, what happens? The path length is increasing. Whether it may be returning or going forward, whatever it may be. If I walk continuously, as the time changes, the path length will be increasing or stationary. If I stop, the path length will be does not change. So if I walk through a road, the walking distance never decrease, it will be increasing. If I stop, okay, path length will be stationary, fixed. So the path length will not decrease. The path length will not decrease. I am continuously traveling, so path length will not be decreasing. Whether I am going forward or backward, the path length is actually increasing, never decrease. Look here, what happens is, here initially the path length is increasing. After that the path length is decreasing. This segment is impossible to occur. This means that the path length is decreasing. It is impossible. Path length will be increasing actually. So does not represents one dimensional motion. Reason, path length never decrease. Never decrease. Okay.